Okay, so we continue on. Now let's add a inspector variable or exported. So we create using the add export var area range and type in. So this one here, you see this one area range, and then there's a lot of things that I need to add to the inspector. But first, this one here range, we create another export category. So the name for this will be uh, generator 3 group patch group point 3 group. That sounds good. So actually I made this one on the go, so there's no planning or whatsoever, just on the fly. So hopefully you can stay with me on this one, our journey to create a 3 group generator. So yeah, it will be take a lot of headache. Okay, let's continue on. So group point trees, 3 here we will hold our 3. Where is my asset? Alright, wait, this one we will generate this 3 here for this model 3 I already made. So if you do not have 3 model, you can use cube. It is fine to represent the 3. But if you have a 3 model, use them. So this is the 3. Now then, go to the 3 group and we create a new. Called export. This one will be our 3 scene. So we can name 3 model. 3 model. And then we use a type hint called the type hint. After you write the variable name, you use the colon, and after the colon is the type hint. So in this case, a scene pack. Or not scene pack, it is pack scene. Sorry, I forgot many times over. So actually I use a notepad and I confused or why I cannot drag and drop the scene here to the inspector, because I use a notepad, not a pack scene. Okay, so 3 model pack scene. And then you see in the inspector we have this 3 model area range, and this one you can load your 3 model or 3 scene. Because when this is not a mesh only, we can instant anything with this way. So we take the green and put it in the 3 model. So this one here is our 3 already in the inspector, the area, and then another export var. This will be our 3 count. 3 count in each patch. So 3 count, type hint in. And then in the export, we can also use the export range. Export range allow you to specify the minimum and maximum size of the of the tree count or integers or float point or float values. So I forgot this one here, the name, semicolon, no, whatever. So export range, and then that one parenthesis, and we will the count limit to 0 or no 1 until when each pair group will be have 5 or 6. 6 too much, 5. So we have 1 to 5 in each patch, and then we refresh back, and then we have the count. And then what else? And then let's create a signal so that we can update our whatever we change onto the scene here. So at the very top we create our signal call refresh, no, update, change, update sounds good. Signal updated. Let's put gen so that we 3 gen updated, so that we know that the signal is for the 3 generator update, whether we change the pack scene or we change the range or we change the tree count. When this one change, the signal 3 gen will updated, or yes. And then we go to the node tab. There is no signal, and then we refresh, and there is the 3 gen update. So we connect to our 3 group node, and in the script you have the newly created signal function on 3 gen updated. So when any of these in the inspector we change, it will fire up the signal, and then the signal will run this function on 3 gen update. So for example, and before, for example, or not example, actually we will do it. All right, print 3 generated updated. All right, so we will print this text. So before so to make sure that the when we change the signal or not signal in the inspector here, variable in the inspector, we need to use the set and get function. If we do not use it, if we change this one here, this signal will not updated. So let's first open the output, and there is no, it should be print this one, right? The 3 generated, but it doesn't print anything. So we need to use the set and get function. So in the export range, I first get the set in the 3 count. We need to use a semicolon to indicate that we will use a set and get function in for this variable. So a colon, and then tab, we use a set, and then this is a new 3 count that we hold a temporary new value that we change in the inspector, and then another colon, and we get the 3 count. We will change the value to the new 3 count, And then we need to admit the 3 gen updated. So we get the signal 3 gen updated and then dot emits. So when this 3 count change, the variable will change to the new count, and then it will admit the function for the signal. And then when the signal here the know that the 3 count already updated, it will print, it will execute this function. So let's test it. Open the output and I change the 3 count. There's no printing. Maybe I need to reopen. If the tool or the script doesn't run in any way, you can just close the thing and then you open up again. And there we have it, our group point, and then this one here, the node that we generated. So if we change this one, you see in the output the 3 generated updated. Yay, congratulations, our first step toward generate a 3. So we have generate our cube point, and then what we will do is actually generate a 3 around this node cube point here, and then add the 3 in the 3 node here. So for example, let's just for each point we generate 1 3. So where is my 3 model? This one here. So this one point will have 1 3, and this one we have 1 3, this one we have 1 3, this one we have 1 3, and this one also we have 1 3. So that's the behavior that we went. So let's create this one. So we have our 3 model, area, range, and 3 count. Now how exactly we need to do that? First we need to create a while statement within a while statement. What I mean by that is, for example, I create a new 2D and then create a new script. This is I just create a test code. So what we went actually, so we use a while statement to generate our cube right at the beginning. So let's get what we went actually like this one. First we get the point, and after we get the point, we want to generate, for example, like this one point, and then we create 3. So for example, each point has 2 3. So this one we have 2, and then another point, new point. This new point also will have 2 3. This kind of behavior that we went. Sorry, so it will takes a while because I never remember stuff so well, because I always reference my previous code and all that stuff, open up web browser to see the code that someone else write, or to look up function, whatever, because I'm very very dumb. Not dumb actually, but not that smart. So for example, var c, this for our loop count, and and then we test the scene. And we generate a 2 1. We print 1 2. Actually I need 3, but this one actually 0. So let's using the point analogy. So this one we generate point, and then when this one run, we also need to run another while loop, two while loop inside a while loop, inside a while statement. So we have a 3 point, and then this 3 point, and then within this point we need to generate another 2 sub point. So first we generate point, and then using the while loop var sub count sub c sub c less than sub point, we print 2. So then sub c plus equal 1 to end our while statement, and then let's run it. So we manage 1 1 2 1 2 2 1 2 2 1 2 2. So 1 2 1 wait 1 2 3. Alright, so this is the behavior that we went. First we get the point, and then we generate the sub point within it. So we get 1, and then 2 2, and then another point, and then 2 2, and then another point, and then the sub point 2 2. So this the code that we will implement to generate our tree. Alright, I think it is alright actually. Is there anything? Yep, that's correct. Sum c, and then plus. Oh, and then also actually no, because because we doesn't have to reset the sub c count, because our while count while statement will repeat itself and then create a new sub c equals 0. Alright, so this will work out. So go to our node tool scene here, and I'm going to delete this tree. Maybe let's just set it for this one. Yeah, okay, I just delete them.